Hi, I got a very important question from one of my students about PCB variants. What is the purpose of variants and why do they matter? Why do you even do them in the schematic and electronics design? Well, in this video, I'm going to break down why you would use variants and how to apply it and use them in your ECAD software. Shout out to Altium for sponsoring this video. I'll be showing it in Altium. But first, let's talk about variants. The biggest point of variants in schematic and PCB design is allowing you to have one schematic, but multiple versions of a printed circuit board. Meaning you have one schematic, one PCB with one set of traces, but you can populate certain components on one board, certain components on another of the same PCB. So we're talking about the same PCB material, but you have parts populated in section A of the PCB and parts not populated in section B, and so on and so forth. You can have multiple assembly variants, meaning components on different areas of the board to have different versions of a product. So think about this. Maybe you order an oscilloscope, right? Or you order a computer, whatever. You can have one schematic with a full set of components that are on there on the bill of materials list, right? And to have the best version, let's say, of an oscilloscope, like the $3,000 version of an oscilloscope, you put all the components on that board. And that's one variant. That's let's say, the highest product tier of that oscilloscope. Then you have tier number 2 of your oscilloscopes that have some of the components missing off the printed circuit board and that only give you, say, 80% of the features as the tier 1 product, that top tier product that has all of the features, 100% of the features. And then you can probably guess tier 3 may have even fewer components that enable only 50% of what the board can actually completely do. So now you have one schematic, one PCB, same traces, but now with 3 different sets of components on the same board, you can now release different product tiers, selling them at different price points, but without having to change your schematic or your PCB layout. That has pull-up resistors, or in this case does not have pull-up resistors. And so I need 2 pull-up resistors, one on the I2C SCL line and one on the SDA line. Don't worry about the lines. And these resistors, I need to put 2 external pull-ups on here. And like, okay, cool, we need that. But let's say I get another version of U2 that has internal pull-up resistors. And therefore I don't need these 2 resistors, right? Maybe, depending on stock availability or whatever, I want 2 variations of the PCB. Variant 1 has the pull-ups on the outside of the chip. Variant 2 doesn't have any. Okay, so here's what I would do. The engineer would create 2 variants like what I show here on the design, same schematic. And if I look at power management, the variant version 1 shows this. The 2 resistors are there. I'm going to pull up the PCB to show you that the resistors are there as well. R4, R3. Let's double check, right? R3 and R4 are there. Fantastic. Now let's go to variant number 2. If I go to variant number 2, power management, and then double click on there, boom. Let's assume also that this chip has changed to where it has an internal pull-up resistors. Now I have the same schematic. It says these components, don't place them on here, right? And when I check the PCB, the footprints are there. But not the 3D model, not the device itself. This is just a quick example of how you can make a variant and what it looks like in practice. Okay, maybe I want to ensure that, like I said, just given the example, the chip doesn't require external pull-up resistors, so I would have a version that doesn't populate the pull-up resistors. And then you have all these other components here. And if you want to see the finished PCB, that's what it looks like. Okay, wanted to show you something cool there. All right, so that's pretty much it. So now we have an understanding of variance. Now I want you to be careful. Once you start dealing with variance, you need to be aware your bill of materials are going to change. Okay. You're going to have multiple bills of materials. You're also going to have a different variant. So a variant for your assembly drawings, right? You have assembly drawings that do not show the components that shouldn't be on there, like R3 and R4. The fabrication files and the PCB traces will be the same, those Gerber files, but not the assembly drawing. And again, the bill of materials will be different depending on which variant of the PCB you're working with. Okay. You may also have to worry about simulation configuration, and your netlist should be the same, but your pick and place file will be different when you send your files out for manufacturing. Some common mistakes that could be made is not having your design, your original design and your variant versions of your software in sync, well, of your schematic in sync. This is what happened when I worked at different companies and at Intel as well. We had multiple different variants, even design reuse. When you have design reuse in the mix, that adds more issues to the problem, where we had a completed PCB. And but the problem was some of the team got laid off in a different country altogether. And I had to reverse engineer the reuse circuit and schematic and also the variants that was used, make that final version of the PCB without breaking the other parts of the schematic design. It took me 2 months to do that. Okay. So if you'd like to learn about best practices when you're dealing with variants or schematic and PCB design in general, click the link below. I have a guide or resource at Hasofu that will help you with that. Also below is a link to Altium Develop. This is the only ecosystem that fully addresses the full workflow for hardware design engineering, including requirements. So I strongly suggest you click the link below and check it out. That's what's on my screen now. You have Altium Develop, really great. I mean, Altium is doing big things here. And I'm not just saying that because the video is sponsored. And I'm going to have a more in-depth video explaining how this allows you to execute PCB and hardware design so you can get first-time right designs consistently and with team collaboration and with any ECAD software you're working with. Well, almost any, the most popular ones. So last note, if you are serious about being a professional in printed circuit board design and hardware design, not saying if you're not, if you haven't worked with variants, you're going to eventually run into variants at the enterprise level if you haven't already. Variants within the same design are how the professionals do it without having to have 5, 6, 8 different copies of a schematic with small little changes. You don't do that. You want to work with variants. All right, so share this video if anyone's ever wondered what variants are or didn't even know what variants are in PCB design. And I'll see you in the next video. Like, subscribe, follow, whatever the case is, and I'll give you some more tips on enterprise level PCB design.